important topic that we need to understand. We have already discussed one important chapter. That was the first topic that we discussed. One that was vectors. We started with this only, right? So in vectors, we learned about the triangle law and parallelogram law of vectors, right? So this is what we have learned. Then, with the help of these two bases, we discuss the concept of projectile motion. Am I right? So we did projectile motion, and then we discussed many problems also, right? So for a particle to move in a projectile motion, what is the trajectory followed by it? It is, I told you the name already. It starts with P. So the trajectory followed by a particle in projectile motion is?
Parabolic path.
It is parabolic in nature. Means it's a parabola, right? The next, see, parabola is a two-dimensional shape. Okay. The next concept of motion in a plane. Plane means what? Plane is two-dimensional. The next important type of motion that we are going to discuss for today is circular motion. This is a very, very, very important topic. Why I'm saying very important topic is because, let me relate this to your chemistry and explain. It is not only in your chemistry, it is applicable in many places. As of now, the best example that I can give you is what you have learned in chemistry. Okay. So in chemistry, you have learned a topic named atomic structure, right? Did you learn or not?
Yes, sir.
So in atomic structure, you would have learned about the Bohr's postulates. Means whatever is a statement that was made by Bohr with respect to the structure of an atom. In that, he would have used a concept called as orbits. The electrons revolve in particular orbits where the angular momentum, something like that, is quantized, right? So what is the shape of the path he has mentioned with respect to the particles revolving? So electrons revolve around a central part which is called as a nucleus. In which path? Do they parabolic path? Do they go in an elliptical path? Do they go in a circular fashion? What exactly happens there? You have a central nucleus. Around the central nucleus, there are electrons, and the electrons are going to revolve in which motion? They are going to revolve in a circular motion, right? So the circular motion is not the important point here. So you would have learned it theoretically saying that the particles are revolving in circular motion. The electrons are revolving around the nucleus in circular motion, right? But the important question here is, what is the important question that you need to answer here is, what force is making this electron get bound to the nucleus, which is making it revolve in a circular motion? Can someone tell me the answer for this? So let's say the radius is r. Did you guys learn this kind of formula? Rn is equal to 0.53 into n squared divided by z angstrom.
Yes, sir.
Yes or no? You have learned it, no? So how did you get it actually? See, unfortunately, in chemistry, they cannot teach you the derivation because you need to know this concept. Since this is the very first chapter, they would have not taught, but I'm trying to relate the concept so that you can understand better. Okay. So how did you get this? Like, what is the nature of the force that is existing between the nucleus and the electrons, which is making the particle be in a circular motion? What is the necessary force there? Anybody who can explain it? That starts with a term called, with the letter C.
Centripetal force.
Very good. It is called as centripetal force. Now, the topic that we are going to see today will give you an answer of what is centripetal force. So what I wanted to do is, I wanted to summarize all the topics that we have discussed till now and make you understand that they are all are related. Okay. So, just a minute. Before I switch on my video, I would like to give you an important note. Till now, starting from chapter 3 till end of chapter 4. So what is the name of chapter 3? It is motion in a
Straight line.
straight line. So name of the fourth chapter is motion
In a
in a
plane.
plane. So straight line means one dimensional. Plane is two dimensional. Am I right? I hope you are able to understand. So
Yes,
here
sir.
our main concept was, or the main concentration was on the motion of the object. We never discussed a concept saying what made the object move in the direction. For example, if I say, when you solve the problem based on motion in a straight line, they would have told you that the car is starting from a particular point with this particular velocity, let's say 50 meters per second. With what velocity it is going to reach this point, provided it is accelerating with this much value. Something question can be framed like this. Did anywhere the question mention stating that there is an engine in the car which has produced this much of power due to which it has moved, something like this? Was there a question like that? You would have not seen. Right? Similarly, when you discuss about the concept of motion in a plane, we would have discussed saying that there is a particle which is projected with initial velocity. That's it. No question of who is projecting, how much force they are applying, how much momentum they are giving. You would have never learned these kind of words. So I've already told you. So these two fall under a branch of physics which is called as kinematics. I've explained this term. You guys remember? So what do you mean by kinematics? It is motion of an object without being concerned about the cause. But have one point in your mind: for any object to move, you need to apply force. Okay, so that's what we are going to see in the next chapter, chapter 5, that is laws of motion. There we will start learning about what are all the forces. So in these two chapters, if you observe, these two fall under a branch called as kinematics. So in kinematics, what is our main concern? What is our main part that we are going to study? We'll be concerned only about the motion and not cause. Am I right?
Yes.
So this also we have seen. So when we discussed about the motion in one dimension, we discussed, see, let me tell you all the concepts. So when we discussed about motion in one dimension, we discussed about the horizontal motion, like the motion of a vehicle. Then we discussed about vertical motion. When I say vertical motion, what comes to your mind? Motion of an object under the influence of gravity. So under the influence of gravity. So these were the two main concepts that we were concentrating in motion in one dimension, and we tried to solve all the problems using 4 equations. S is equal to ut plus half at square. All those 4 equations are there. We use nothing outside it. Similarly, when we discussed about motion in 2 dimensions, what was our main concern of study? We discussed about projectile motion. So projectile motion also, for a projectile to move, what is the necessary force that is going to act? It is also moving under influence of whom? Gravity. It is still moving under the influence of gravity only. At least for what we have learned, we are trying to learn in a gravitational field. Am I right? Right. So the next concept that we are going to concentrate is going to be circular motion. This is what I told you. Now I am going to summarize and show. Let me show you certain activities. They're not very complicated, simple activities you guys can understand. You can tell me those are all examples of what. Okay. So I'm switching on my video. Let me know if you guys are able to see me. Are you guys able to see me?
Yes, sir.
I am not able to see. Just a minute. Yeah. See, this is what I got in my hand, a charger, okay? A simple charger where I'm going to detach this. So if I take this as a particle, guys, if I take this as a particle, now if I try to keep it on my hand, okay? If I try to keep it on my hand and I'm saying this particle is moving on my hand, this is an example of which kind of motion?
One dimensional.
One dimensional horizontal motion. Am I right?
Yes,
so
sir.
if I keep my hand like this, I'll go a little back. So if I keep my hand like this, from here, I'm dropping this object. When I say dropping, I'm going to drop it like this. So if I take this as the ground, I'm dropping. Wherever you see the word dropping, what is the velocity I'm giving to this object?
0.
I'm giving a velocity of 0. And if you observe what are all the forces acting on this, only force that is acting is the gravitational force. But we never speak about gravitational force. Rather, we speak only about the acceleration due to gravity. We speak about acceleration only. We don't speak about force. So G is acting in the downward direction, and we use the G value and try to solve all the problems by calculating how much time it is going to take to come down and all those things, right? So this is an example of what? Motion in one dimension, but under the influence of gravity. Or else I could have done one more thing also. I could have given the velocity to this object. It would have gone up. It would have stopped here for instantaneous. It would have come for an instantaneous. Again, it will come back to its position and fall down. So theoretically, what is that we learned? If you are trying to project the object upwards with the speed of 5 meters, it will go to this point. At this point, 0 will again it will come down and hit the surface with how much speed? So projected with 5 meters per second, with what speed will it hit the ground again?
5 meters per second.
Same.
It will hit with the same 5 meters per second, provided what is ignored?
Air resistance.
Air resistance is ignored, right? So this is what we learned under the motion of an object under the influence of gravity. So most of them, what they think was under the influence of gravity means. Just give me a minute. Okay, so most of them, what they think is more under the influence of gravity means only downward motion is possible. No. If the object is moving upwards also vertically, provided the only force acting is gravitational force, it is still called as motion under the influence of gravity. Okay, that's what we learned in the first chapter. Now in the projectile motion, what did we do? We kept the particle like this. You are able to see, no? So I'm neither giving the velocity like this, nor am I giving the velocity like this. So I'm giving a combined velocity of this and this put together, such that I'm trying to project it in such a way, then the particle will go like this and it will come down and hit some other point. Right? It is going like this, it is going and coming and hitting. So what exactly is happening? It is given a velocity like this. So what is the direction of velocity? When it is projected in this way, the velocity is always tangential to the surface. This is the direction in which the velocity is given. So when this is traveling, no, look at the way that the velocity is also going. Are you guys able to understand what is happening? You're able to see my pen, right? This pen is going to be the tangential velocity. So when you give a velocity to the object in this direction, just give me a minute, guys. Okay. See, the particle will have the velocity in this way. This is the direction. See, this is the direction in which the velocity is given. Velocity is always tangential to the surface. So if it is projected from here, it goes like this and it comes and falls like this. So at the highest point, we learned this thing. No? When it goes like this, at the highest point, what is happening? You will have only the horizontal velocity that is existing. That is u cos theta. And then again, it will come in this direction and hit the surface. I hope you guys are clear till this point. Is there any doubt? You're able to visualize slightly, right?
Yes, sir.
Right. So this is one such example. The other example is sometimes what will happen is there is a building like this. Okay. Take this remote as the building. I'm standing on the top of the building. Sometimes the particle will be projected like this. It will be given a horizontal velocity. When it is given a horizontal velocity from certain height above the ground, so previously what we learned is the particle is projected from the ground, it goes like this and again comes and hit the ground. Sometimes what happens, you will stand on the top of a building, means you will give a horizontal velocity, it will come and hit the ground like this. We did one problem also, if you guys remember, calculating the speed, last class we did. It was slightly a lengthy problem. You guys remember that? Are you guys there? Are you able to understand what I'm trying to say? Yes or no?
Yes, sir.
Okay.
Yes.
Listen. Now what I did is, initially I treated this like a particle. I have the same charge. If you want, you also can try it. But don't break anything. Just try it for you to have a feel of it. Okay, you can get a charger and come if you want. See, I've connected my charger to this. I'm going to treat this like a string. You know what is a string, right? Like a thread. Okay. The thread is connected to a particle. If you want, you can take a small stone and tie a thread around it and do this activity and see also. If I drop this charger, then see, I'm not going to drop and show, but you people tell me how it is going to go. If I drop this particular particle, this box, is going to travel in which direction?
Downward.
It will travel completely in a straight line, or it will go in some random path, assuming the air resistance is ignored. There is no force in this direction.
Completely straight path.
So
Straight path.
completely straight path, it is going to come and fall on my hand. It has fallen. Yes. Okay. It is no forces hold it. Now see, the same particle, what I'm going to do is, I'm going to pull the string, I'm going to hold it at this point. Now I'm going to release this. Okay. So initially I didn't hold it. Now I'm trying to pull it, make this tight enough, and I'm going to leave this. In which direction will it?
Right hand side towards positive x-axis.
So how will it move?
Like a pendulum.
Will it move in a straight line path or something else?
Parabolic path.
So let's see. So what exactly happened? I held it like this. It was traveling like this. Am I right? So the other way I'm going to do this is, see, it might fail also, it might fly. I'm trying it, okay? So I'm holding it like this. I'm giving, see, observe, I'm holding it like this. I'm giving a velocity to this object in this direction. Okay? When I'm saying I'm giving velocity to the object, observe, whenever you talk about a two-dimensional motion, the velocity is always tangential to the surface. Means I'm trying to give a velocity in this direction. So how am I going to give? I'm just giving it an impulse. Impulse means I'm just hitting it like this. Okay. I'll hit it strong enough such that it is able to come like this and move. Okay. Now I'll ask you one question. You people have to tell. I'm not holding it here. Okay. I'm not holding it here, or it is not tight enough. If I give a velocity to this object without holding anywhere, in which direction will this move?
I'm not able to understand the question, sir.
See, if I keep this charger right, I keep the charger like this, I give velocity without holding anywhere, in which direction will it move? Let's do and see. I'm keeping it like this. I'm not holding it anywhere. Okay. I'm not holding it anywhere. Means this is there. If I give it a velocity, okay, let me take this as, are you guys able to see?
Yes,
Yes,
sir.
sir.
If I give it a velocity, in which direction will it move? It will tend to move in this direction. So what path is it following?
Right.
It is following a straight line path. But if I hold it like this, and if I give it a velocity, observe what is going to happen. What is happening? Is it? So previously what happened, when I gave it a velocity, it was moving in this direction. Right? Because I didn't hold it anywhere. Now I'm holding it at this point. I'm giving it a velocity. Are you guys able to see what is happening to it? What is happening?
It's bending.
It's bending and trying to come towards me. Means if I have, let's say I'm fixing a compass across this. Okay, I have a small, I fixed a small pencil tip at this end. Let me say this is the paper. If I keep it on a paper, if I hit it like this, what do you think will be the path followed by that pencil?
Somewhat circular.
It is somewhat circular, no? But actually speaking, it's going to be a circular motion. Okay, so what I wanted to conclude from here is, Because most of them have a confusion between the parabolic path and the circular path. You need to have a clarity. Okay, try to understand. I'm repeating it again. Listen. When you try to project a particle like this, when I projected the particle, if I don't have any force that is holding except the gravitational force, if it is moving only under the influence of gravitational force, it will move in a parabolic path. But here, what am I trying to do is, I'm trying to make it like a string and I'm giving it a velocity. So, I'm trying to hold it here and I'm giving the velocity in which direction? Can you tell me? Which direction with respect to the way I'm holding it, am I giving it the velocity? So I'm holding it towards me. I'm holding it towards me. I'm giving a velocity in this direction. So the string is towards me. I'm giving the velocity in this direction. So what is going to be the angle?
0.
I'm repeating it again. The string is towards me and my finger is like this. This is me. This is the direction. Towards
90
me.
degrees.
This is the direction of velocity. It is 90 degrees.
90 degrees.
Okay. So you can ask me, what am I trying to do by holding the string like this? Is I'm creating a force in it. Have you ever experienced it? Have you ever, like, you can take the charger now and see. If I hold it like this, it is hanging. No, sometimes I can see, I pull and hold it like this. What I'm trying to do is I'm trying to pull in both the directions. So here, if you observe, the string is having a bend. But if I try to pull it and hold it like this, it is going to be straight. Now, the name of the force that is going to come in the string is called as tension. Have you heard this word tension?
Yes, sir.
Yes,
So, what I'm trying to do is, I'm trying to create a tension in the string by holding it tight. Okay. Now, tell me, by holding it tight, in which direction is the tension acting? So, when I hold it like this, the tension is acting towards me. Because I'm holding the string like this. The tension is acting towards me. And the velocity is given in which direction? Velocity is given in the direction perpendicular to tension. Are you guys able to understand this point? So
Yes,
tension
sir.
is the force, velocity is in this direction. So if there is a particular motion where the force and velocity are always perpendicular to each other, that kind of a motion is what is called as a uniform circular motion.
Can you say it again, sir?
So if there is a motion where the force and the velocity are always perpendicular to each other, that kind of a motion is called as uniform circular motion. Are you guys able to understand this point? Okay, now I will tell you the difference. The reason I had to stress this much is, I'll tell you where the confusion will start. So concentrate. I'm sharing my screen. So what happens in a projectile motion is, so one concept that will go into your mind saying that the velocity of a particle which is moving in a curved path is always, so when it is moving in any curved path, it can be any random shape. If I want to find the velocity at this point, how will the velocity be? It will be tangential to the surface. I hope this point has gone into your mind. I showed you with the help of the pencil, no? I held my pencil tangential and I showed it to you. Yes or no, guys? I want some response.
Yes, sir.
Clear, right? So, when we talk about projectile motion, projectile is a parabolic path. It is going to be something like this. So, projectile motion means it's a parabolic path. So, if I want the velocity at this point, it will be tangential here. If I want the velocity at this point, it will be tangential. If I want the velocity at this point, it is going to be like this. Are you guys able to understand? So, when the object was going in this particular way, under the influence of gravity, okay, this is u, this is theta, u cos theta, and u sin theta. Okay. So, what is the only force acting on this object?
Gravitational.
It is the gravitational force. Now, tell me one thing. Is the gravitational force, is the force and velocity always perpendicular to each other in this motion?
No, sir.
No, right? If you observe the velocity here, if I call it as v1, here the angle is obtuse. Here G's direction is fixed. Here the velocity is 90 degrees. Here the velocity is making an angle of acute angle. Here it is making an acute angle. So if you observe in a parabolic path, what is happening?
Sir, tangent means perpendicular only, no, sir?
No, perpendicular means normal. In ray optics, you would have learnt, no, the incident ray, reflected ray, and the normal. Normal means perpendicular. Tangent is along the surface. Are you guys able to understand this point?
Sir.
So, in a parabolic path, if they ask you, force and velocity are not perpendicular always, but there is only one instance where it is going to be perpendicular. Where is it? You can get it as a 1 mark question.
Middle.
At the
Maximum.
the highest point.
Highest
Or
point.
middle line. It is called as highest point or maximum height. Okay. So this might be a 1 mark question. Whereas, what did I tell you? This is my charger. Okay. This is my hand. Okay. I kept this whole thing on a table. This is what my table is. Now you have to visualize only because I cannot show more than this. So I was holding this point tight. See, I'm putting a red dot. At this red dot, I was holding it tight. By me holding it tight, what will happen to the string? Will it be curved or is it going to be straight? The string will become
Straight.
due to what?
Tension.
Very good. Due to tension. So the tension is acting towards me. Tension is represented by the symbol T. And in what direction did I give the velocity? Are you guys able to visualize it? Now you are able to visualize.
Yes,
So
sir.
I have given a velocity perpendicular to it. So what has happened is, if the string was not there, the particle would have had the tendency to move in a straight line path because that is the direction in which velocity is given. But this tension and velocity put together, the particle will neither be able to move along the horizontal nor the vertical. Rather, it will start moving in this way. Means it will get curved here. Okay, I'm trying to describe each and every step. Let me say this point is O. The particle has gone from A to A dash. Okay, let us say it has taken a slightly curved path. I still don't know what motion it is. I told you, no, below this charger, I'll keep a pencil and I'll observe the way the dots are being formed. Okay, so when it has gone here, my hand is fixed. Now, how will the tension be? This is my hand. So at point A dash, again the tension will be towards me. But what will happen to the velocity here is, it is going to be tangential at this point. Are you guys able to understand?
No, sir.
Sorry?
Sir, can you repeat once, sir?
Did you understand this curved path? From A to A dash, what is happening? Did you guys understand?
A dash only I can understand, sir. Tangential path.
At A dash, what will happen is, the velocity is tangential like this. See, not only at A dash, guys, try to understand. If I ask you what is the velocity at this point, it will be tangential.
Sir,
Okay, 1 minute. Let me explain it. See, when I take a circle like this, you have learned tangents last year, right? From an external point, if you draw two tangents, they are of the same length. All these things you have learned in 10th standard.
Yes, sir.
You have learned it, no? So tangent means what? Tangent is a line which touches the curve at one point. But here what is happening is, I'm not drawing the tangent as a line, rather I'm drawing it like a vector. So what I'm going to do is, I will draw it like this, but I need to choose the direction. I'm trying to say that the particle is revolving in the anti-clockwise direction when I see from the top. Are you guys able to understand this point? So the particle is revolving in anti-clockwise direction. So if I want the velocity at this point, it is going to be tangential. But tangential, which direction should I draw the arrow mark? The arrow mark should be drawn in the direction in which the particle is trying to move. So I don't need the bottom part. That is the only difference between mathematics and physics. So in physics, you're not. So in a similar way, what will be the velocity at this point? What will be the direction of velocity at this point?
tangential.
Again, tangential. In anti-clockwise or clockwise direction. Something like this. I hope this point has gone into your mind. In a similar way only, I'm saying there is some random point A dash. Okay. Forget about A dash. Now what I'm going to do is, observe clearly. So this point, you're convinced, right, that it is tangential in the upward direction. I'm trying to mark that point. Tell me yes or no. At this point, did you guys understand?
Yes.
That point you have understood, no? So at this point, how is the tension going to be? The string is still connected to my charger. In which direction will the tension be? It will be like this. Now, what is the angle between tension and velocity at this point? You're able to see, no? What is the direct angle between velocity
90
and
degrees.
it is still 90 degrees.
90 degree.
Okay. Similarly, at this point, it will be velocity will be like this, right? So tension will be like this. Still, it will be 90 degree. I drew a bad diagram. I'm sorry. Okay. So what exactly is going to happen is, observe. I'll show you a clear picture. Concentrate. Okay. One minute. Right, this will give you a better picture. Observe. This is my hand. This is the charger. Okay, this is my hand. My hand is fixed. The charger is given a velocity in this direction. Accepted? Right. It will move like this. If there is a particle which is moving in this particular path, when it comes here, what is going to be the direction in which it is going to have the velocity? It will be tangential. Right. So if I join from here to here, now this is the first position of my string. So first position of my string, the tension is towards me. This is the second position of my string. So at the second position, what is going to happen? The tension is still towards me. Now what is the angle between the tension and velocity at this point? It is 90. At this point, what will happen? That will be the third position of the string. Still the tension will be towards me. Velocity will be like this. Are you guys able to visualize it better? So you're able to see what exactly is happening at each and every point. Tension will be towards me. Velocity will be like this, 90 degrees. So what did I say? If force and velocity are always perpendicular to each other, then what is the name of that motion?
Circular.
It is a uniform circular motion. I should not only say circular, it is uniform circular motion, because now I am discussing only about uniform circular motion. Okay, please make a note of it. Please make a clear note of it. If there is any doubt, let me know. Okay. Now I will give you certain terms, try to understand. So what we are trying to learn is circular motion. Right. So if you have to give a simple definition to it from the name, what will you say? When can you say a motion is circular motion? When a particle is moving in what kind of a path? In a circular path.
Circular path.
As simple as that, nothing outside this. Okay. Now the question is, when the particle is moving, what are all the physical parameters that are involved behind it? Okay. So basically, circular motion is classified into two types. One is called as a uniform circular motion, and the second is called as a non-uniform circular motion.
No doubt, sir.
Tell me.
Sir, you said no, sir, that A dash A and all.
Mhm.
So at any point, it will be perpendicular, sir.
At any point. At any point.
Is there any law, sir, to like frame it?
No, that is an experimentally observed one. I couldn't actually see. I tried to show the activity, but I need a top angle camera for you to see it clearly. It is difficult for me to show. You can actually try this and see. It's not a big deal. What you can do, you can take a small stone. My charger is a little heavy. You can, instead of the charger, you take a small stone, tie it to the thread. Make sure you keep it on your table and try to give it a velocity. Okay. What you can do is below that stone, try to have some black color dot and place it on a paper and hit and see. The way it will move, no, it will be a circular path. Are you able to understand what I'm trying to say?
Yes, sir.
You try and see, no, you will get it. Do it as a small activity. If somebody is getting it perfectly, you can share it with me. I'll put it on the group. Okay, you can try it as a small activity and see. Maximum time it takes is 10 minutes. Okay. So uniform circular motion and non-uniform circular motion is similar to motion only. In motion, we have two types of motion. One is uniform motion and second is non-uniform motion. So when do you say motion is uniform?
Equal time and speed.
In equal intervals of time, it is going to cover equal distances, or okay, it is going to cover equal distances. So can I say that the velocity of the particle is going to be constant throughout its journey?
Yes, sir.
Yes, sir.
So if I see, try to understand, when I say motion, I'm calling it as uniform motion and non-uniform motion. So when I say uniform motion, what is going to be constant? Velocity is constant. And what about the acceleration? If velocity is constant, what is the acceleration, guys?
0.
It is 0. Whereas in non-uniform motion, what will happen is velocity will vary and acceleration will be non-zero. Whether acceleration is constant or not, that is not our headache. Okay. One thing I can say is when I see the word non-uniform motion, I can surely tell one thing, that acceleration is not equal to 0. Okay. Between this uniform and motion, there is a term circular that is involved in it. Okay. Then what do you think a uniform circular motion will be? Its velocity is constant and acceleration is 0. So if there is any doubt, let me know. Is there any doubt?
No, sir.
No, right? But here I have to tell you one important point. I told you about this tension. No? This tension is a force, and this tension is what is called as the centripetal force.
Sir, can I just give a definition for centripetal?
Centri means center. Petal means loving. So something which is seeking towards the center is what is called as centripetal force. To put it in very simple terms, the force which is acting towards the center of a circular motion is called as centripetal force. Are you guys able to understand this? Okay.
So the force at any point will come towards the origin, sir.
Need not be origin, towards the center of the circle.
Sir,
Center.
origin is a center, sir. Center only is just origin, sir.
You took it as okay. Don't do that mistake. Not every time it is going to be origin. That is why I'm stressing. So you remember it as, don't use the word origin because that will go wrong. Use the word center. Okay. This force is called as centripetal force, and the acceleration that is acting towards the center is called as centripetal acceleration. So for a circular motion, there are two types of acceleration that we will be describing. One is called as centripetal acceleration and the second is called as tangential acceleration. So tangential, the name itself is suggesting. What do you mean by that? It is along the tangent. Centripetal means it is towards the center. In some books, centripetal acceleration is also referred to as radial acceleration. Okay. You can either write it as AC or AR. Both mean the same. Why we call it as radial acceleration is because it acts along the radius. Are you guys able to understand? So
Yes,
for
sir.
uniform circular motion, one important point you need to be very careful about is, you wrote the acceleration is 0. But tell me one thing, velocity is there, no? With respect to uniform circular motion, how is the velocity of the particle? Is it acting along the tangent or along the radius?
Sir, can you come again, sir?
I'm saying motion is the velocity acting along the tangent or along the radius. Let's test on this point 2-3 times. Velocity for any curved path is always what is it?
Constant.
Lada, I'm asking the direction. Velocity of a particle along any curved path at a particular point is always. What is the line that I've drawn?
Perpendicular.
Tangential.
Tangential. So velocity, if you observe for circular motion also, did I draw the velocity? Did I draw it along the tangent or along the radius? I'm asking a very simple question. How did I draw? What is the velocity that I've drawn here? Is the question so tough?
Yes, sir.
B is okay. Da? What is the direction? Is it? I'm asking the question directly. Did I draw it as tangent or radius?
Tangent.
That is what I had been asking. No. So here you wrote velocity is constant. Which velocity is constant? The tangential velocity is constant. So you generally don't write it as tangential velocity because it is understood. But for you guys to understand, practice it. Vt means tangential velocity. So tangential velocity is constant means when a particle is moving in a circular motion, what are the two types of accelerations that are present? One is centripetal and the second is tangential. Now, which acceleration among these two will be 0? For a uniform circle, it is the tangential acceleration that will be 0 because if I have dt, tangential acceleration is dvt divided by dt. Means derivative of a constant with respect to time. What is the derivative of a constant?
0.
So you need to be very careful. These are all the 1 mark questions that they can ask you. This is where you will lose. It is not keeping the marks aside. These concepts are important for you to apply it in other parts of physics. Okay, we will be using this concept in many chapters. Please be cautious. If there is any doubt, let me know. Because at that point, you will not understand anything. So tangential, so velocity is constant, tangential acceleration is 0. Whereas in a non-uniform motion, what will happen? Non-uniform circular motion. The tangential velocity will not be constant and tangential acceleration will not be equal to 0.
So greater than.
Sorry?
So it will be greater than 0, no, sir?
Need not be. It can be less than 0 also. That is not our concern. It is non-zero. That's it. It is a non-zero value. That's it. It can be greater than 0 or less than 0 depending on whether it is accelerating or retarding. That is not our concern. So wherever you see that the tangential velocity is not constant and the acceleration is 0, is not equal to 0, that is non-uniform circular motion. Let me explain it with an example, try to understand now. So when the particle is moving like this, so you people tell me, here the velocity is 5 meters per second. Now it is not tension, okay? There is some particle which is revolving like this. Here the speed is 5 meters per second. Here the speed is 5 meters per second. Is this an example of uniform circular motion or non-uniform circular motion?
Uniform.
So this is an example of uniform circular motion. So what happens in uniform circular motion?
All tangential velocities should be equal.
So the velocity will be constant, but its direction will keep changing with respect to time. Okay. So velocity is direction. Are you able to see the direction?
Yeah, your voice was breaking, sir. Can I explain it again, sir?
I'm saying in uniform circular velocity will be constant, means the magnitude of velocity will be constant. That is nothing but the speed. So here the speed is 5 meters per second, 5 meters per second, 5 meters per second. But what is happening to the direction?
It's changing.
The direction keeps changing. Okay. Whereas here 5 meters per second, 2 meters per second, 3 meters per second, 10 meters per second. What is this? This is a
Non-uniform circular motion.
you guys able to understand? So non-uniform circular motion. Because the speed is changing and the direction is changing, means tangential acceleration is not equal to 0. That is what I'm trying to say. Are you able to understand this point? Okay. So our topic of discussion is only uniform circular motion. Now, velocity is constant and direction changes. One more important point is, make a note of it. Centripetal acceleration is not equal to 0, whereas the tangential acceleration is 0.
Sir, in uniform circular motion, sir.
Yes, in uniform circular motion. In uniform circular motion, the centripetal acceleration will not be 0, whereas the tangential acceleration will be 0. Whereas in non-uniform circular motion, centripetal acceleration will also be non-zero and tangential acceleration will also be non-zero.
Sir, why centripetal acceleration is non-zero, sir?
Because I told you the example of a string. What is acting towards the center? There is a force, no?
Sir?
When there is a force acting, the force is F is equal to ma, at least from your 9th standard formula. When F is non-zero, acceleration is non-zero.
Okay, sir.
Yeah. So what I'm trying to conclude here is, for any particle to be in a circular motion, whether it is uniform circular motion or non-uniform circular motion, what force is necessary? Or what acceleration is necessary?
Centripetal.
Centripetal acceleration is necessary. Okay. Now our next objective is to derive an expression for the centripetal acceleration. Okay. Is this clear? Are you guys clear with till this point? Is there any doubt?
Not sir.
Clear, right? Okay. See, write down the heading as, see, in your textbook also it is given like this only. What is the topic given? 4.11. It is called as uniform circular motion. It is called as uniform circular motion, not only circular motion. So you can read it out. When an object follows a circular path at what? At a constant speed. The motion of the object is said to be uniform circular motion. The word uniform refers to the speed, which is uniform, that is a constant throughout the motion. I hope it is clear till this step. Right. Now our work is to derive what is the acceleration value that is acting towards the center. Now concentrate. Now I'm going to derive the expression for centripetal acceleration. Centripetal acceleration of an object in what motion? Uniform circular motion. Okay. So listen, guys. If I say the velocity here is v1 vector. Okay. I'm saying the velocity here is v2 vector. Okay. Now try to understand what is the type of motion I am trying to describe. I'm calling it as uniform circular motion. So for uniform circular motion, just now I told you that what is constant?
Velocity.
The speed, the magnitude of velocity. That's what. Okay. The speed is constant, but what is changing with respect to time?
Tangent direction.
Its direction is changing, no? So actually, why did I write it as v1 vector and v2 vector? Why didn't I write it as v vector and v? So the first question we need to think of. Did you understand my question? I wrote it as v1 vector and v2 vector. Why didn't I write it as v vector and leave it?
Because the directions are different.
Because that very good. Because the directions are different. See, for you to understand better, what I will do is I will take two perpendicular positions and show you. Try to concentrate. If I take this as v2 vector, I've already told you any vector is magnitude times direction, right? So this is magnitude and direction is given by unit vector. I hope this is clear. So v1 vector will be equal to v into what is the direction in which v1 is acting?
Perpendicular.
No, perpendicular. See, take this as x-axis and y-axis.
Initial.
It is acting in which direction, guys?
By positive y.
Positive y means it is j cap. Can I write it as v1 vector is equal to v into j cap?
Yes, sir.
Okay. Similarly, v2 vector will be what? V into
Minus I.
minus I cap. Did you understand why I wrote it as v1 and v2? But if I try to find the magnitude of v1 vector, it is v. Magnitude of v2 vector is also v. Magnitude of velocity is what is called as speed. At point 1 and point 2, its speed is the same, but what is different? Its directions are different. That is why I had to choose it writing as v1 vector and v2 vector. That's what is done in your textbook also. But they didn't use vector. So in your textbook, try to understand the notation. If there is any symbol written in the bold format like this, if it is written bold, it represents vector. Are you able to understand this point?
Yes, sir.
Right? So I'm just going to follow the textbook derivation. There are different ways. There are 2-3 methods to derive this, but I'm following textbook derivation because I'm not sure how your teacher has taught. I taught it from the DAV.
Could you repeat?
I'm asking how was this concept? What was the derivation that
They
was
didn't
taught?
do this yet,
They
sir.
didn't teach, sir.
They didn't teach it. Huh? Okay, no. So where are they now?
We still didn't start projectile motion, sir.
For us, he's in vector
Vectors.
addition and also.
Same, sir.
Okay. So is this clear till this step? V1 vector and V2 vector.
Yes, sir.
Right? So similarly, from the center, if I take this distance, what is this distance? From O to A, what is the distance called as? It has something to do with the property of a circle. It is the radius.
Radius.
So, but if I put an arrow mark, it will become a radial vector. So, if I call this vector as R1 vector and call this as R2 vector, have one point in your mind. R1 vector and V1 vector are always perpendicular. R2 vector and V2 vector are always perpendicular to each other. Are you guys clear with this?
Yes, sir.
Okay. Now see, I'm drawing a separate diagram. This is R1 vector. This is vector. Okay. If I join it from here to here, I'm taking this as a triangle. Let this be A, B, and C. Okay. Now, do you people remember the triangle of vectors? What does triangle of vectors state? If two vectors are taken in order along the sides of a triangle, then the closing side of the triangle is given by the vector taken in the
Reverse order.
reverse order, right? So if that is the case, what will be the relation between AB vector, BC vector, and AC vector? AB vector plus. So which two vectors are continuous, guys? AB vector is continuous with
BC.
BC
AC
vector
vector.
BC.
Equal to
is equal to what?
AC.
Right? So can I write BC vector is equal to AC vector minus AB vector? Any confusion on this? I just rearranged it mathematically. So BC vector is equal to AC vector minus AB vector. So what is AC vector? It is R2 vector minus what is AB vector? It is R1 vector. So R2 minus R1 is nothing but the difference of those two vectors. Difference in mathematics is represented by delta. So what I'm going to do is I will write this as delta R. Is that point clear? Repeating it again, these are not number follow. One, nothing is remaining is full of stories. You will not even understand if you read. So if there is any doubt, cleared now. All the mathematical steps and showing you. Did you understand why I wrote it as delta R? Delta R represents what? The difference in the position vectors. Okay. So R2 vector minus R1 vector. Did you understand that BC vector is del R vector? Is that clear?
Yes.
Now see,
Yes.
I'm going to take V1 vector and draw it separately. So this is V1 vector. Okay. See, I'll show you for you to understand better. It's like I'm moving this. I've taken V1 vector outside. Did you understand this? Now I've taken V2 vector and I'm joining with this like this. Did you understand what I did? So V1 vector was like this and V2 vector was like this. What did I do? I took them separately. Guys, yes or no? Are you able to understand? Did you see what I did? I took V1 separately and V2 separately. I have joined it together. So what vector will this be? This will be V2 vector. Am I clear with this thing? Let me name those points. P, Q, and R. Okay. Now I'm joining these two. Wait. Now I'm joining these two. Now apply the triangle. So I'm taking the same diagram. I'll draw it again. See, if you're clear with this diagram, I'll draw it again.
Yes, sir.
Okay. So this is PQ. And this was V2 vector. Now I'm joining these two. Right? PQR. Now tell me, apply the triangle of vectors again. PQ vector plus
QP.
right.
QR.
QR, Mithun, concentrate. PQ vector plus QR vector is equal to PR vector. Correct? So what is PQ vector? It is V1 vector. PQ vector is V1 vector. Plus QR vector is what you need to find, guys. This is equal to, what is PR vector?
V2 vector.
Very good. So QR vector is what then?
V2 vector minus V1 vector.
Then what can I write this as? Just like how I wrote delta R, I can write this
Del
as
V.
Delta V.
Excellent. Are you guys clear with these 2 points? Right. So what I will do, I'll stop with this. Okay. I want you to revise it till here and come. Tomorrow I made to complete this. Okay. There are 3 to 4 more steps, but I need to explain the geometry in it. It will take some time.
Sir, so what kind of questions they'll ask, sir, based on
They'll
this?
ask you to derive this expression.
Okay, sir.
Derive the expression for centripetal acceleration for an object in uniform circular motion. It's a 3-mark question. Most of the time you will get it.
Okay, sir.
Okay. So keep, as I told you, keeping these marks aside, you will apply this concept at least to 8 or 10 more concepts in physics in your 11th and 12th. You will easily apply to 8 to 10 concepts in your physics in your 11th and 12th standard. So I really struggle because they don't know the meaning of the centripetal acceleration. They forget the formula. That is the reason I'm stressing and telling you all these points. Okay.
Okay, sir.
Yeah. So revise it till here. In tomorrow's class, I will complete the derivation.
Okay, sir.
Okay. So make a note of it. Just a minute. I will take the attendance here itself. Anand, are you there? Okay, Rohan, do one thing. No, you have the participants list open. Rohan, are you there?
Yes, sir.
You have the participant list open. Tell me if the names are there. Anand is there? It will be in the order only.
Sir.
Yes, sir.
Okay, Anand is there. Akshay Shri?
No, sir.
Akshay Shri is not there. Okay. 1 minute. Can someone make it fast? Akshay Shri is not there. Then Atul Nambiar?
Yes, sir.
Okay. Bhavataini?
Yes, sir.
Divya?
Yes, sir.
Harshita?
Yes, sir.
Abhishek? Abhishek, are you there?
Yes, sir.
Okay, Abhishek is there then. Mithun, I spoke. Panchami, I saw. Pranav? Pranav, are you there?
Yes, sir.
Okay. Adi Shruti?
Yes, sir.
Rohan? Rohan, I spoke. Subiksha?
Yes, sir.
Siddesh?
Yes, sir.
Okay. Surya? Surya, Muthu and
Yes.
Seshadri, both of
Yes,
you are
sir.
there?
Yes, sir.
Vinisha?
Surya Madhu is there, sir.
Yes, sir.
Okay, so only Akshay Shri is not there. Okay. Okay. See, from next test onwards, what I will do is all the test notifications you will get it only through the app. That is, you will be getting an SMS. Okay. I'll not be giving any WhatsApp reminders. Going forward, it is the app only that is going to give you all the communication parts. Am I clear on this? So all the things I will assign a test in front of you itself. There will be an SMS triggered. You have to have a look at it and remember. Got it? So
Okay.
assignments also, many of you were asking me about this thing. this pending status and completed status. No? So the important point is, just because you upload the document, it will not automatically change to completed status. Completed status has to be done by me. So I have to go through it and do it, okay? So from next time onwards, when I give you an assignment, looking at the pending status, you won't get confused saying that you have uploaded it, still it is not going to completed status. It's not an automated system. I have to do it. So the same thing will be followed for exams also. So one more update is, when I'm conducting, see, for example, equations of motion 2 is there. No? When I'm conducting the test, you will have the template like this. So if the question, if it is an assignment related to test, I will put a T in the bracket and give it. So that means test. In the bracket, if I put A and give it like equations of motion, then it is an assignment. So have a clarity about it. Okay. I hope everybody knows to use the app. So this 5 p.m. will be the end time, and 16th July, whatever it is, that will be the date where you're supposed to submit the assignment. Beyond that, it will not be accepted. So most of you, I think you're trying it after the time is over. So you're just trying 5 minutes before and you're failing. So don't do that mistake. Ensure it is uploaded before itself, so that if there is any issue, I can resolve it. Are you guys clear? So if you still have doubt, one day I will give you I'll show you a demo of how to use it also. If you still have any doubts, you can let me know. I'll give you a demo session for it. Is it clear? So any other doubt from today's class?
No, sir.
No, sir.
No,
Okay. So wind up. 1 minute. Wait. Don't leave. So I'm planning to give you few more assignments.